So now that we've discovered the rule that when we multiply or divide both sides of an inequality by a negative number, we must flip our inequality symbol at the end, let's do some practice with solving one-step inequalities with negative coefficients. So we're going to work to solve, showing all steps, check our solution, and graph the solution set. Over here we have negative 3y is greater than or equal to 21. Negative 3 times y, the inverse of multiplying is dividing, and so I'm going to divide both sides by negative 3. Notice that when I multiply or divide both sides by a negative, I have to flip my symbol, so I'm going to do that right away. I'm going to flip it from greater than to less than or equal to. And then negative 3 divided by negative 3 is 1, and 1 times y is y. And then 21 divided by negative 3 is negative 7. So y is less than or equal to negative 7. If we wanted to check our work, we can always check our answer. Let's pick a number less than negative 7. For example, I'm going to pick negative 8. So negative 3 times negative 8, is that greater than or equal to 21? Well, negative 3 times negative 8 is positive 24. 24 is bigger than or equal to 21. And so our answer checks. Now I'm going to graph it. I'm going to graph y is less than or equal to negative 7 because that is our solution set. So remember that negative 7 goes in the middle. 1 less than negative 7 is negative 8. 1 more is negative 6. The negatives go in backwards order, so don't get fooled here. And if y is less than or equal to, that means that I fill in my circle because it could be equal to negative 7. Or less than, so less than means I shade to the left towards the smaller number, negative 8. Also, because my variable is on the left-hand side, my arrow points the same direction that I can shade, and I shade to the left. On example 2 here, I have t divided by 6 is greater than negative 1. The inverse of dividing by 6 is multiplying by 6. And here's where we have this little catch. We have to multiply or divide both sides by a negative. In this case, only one side is being multiplied by a negative, not both. So these 6's cancel out. T, my sign stays the same because I didn't multiply both sides by a negative. I only multiplied one side, so my sign stays. And negative times a positive is a negative 6. If you're unsure or you think, I don't know, do I need to flip the sign or not, check your answer. Do a quick check over here and say, okay, well, a number bigger than, let's pick a number bigger than negative 6. Let's pick 0. 0 divided by 6, is that greater than negative 1? 0 divided by 6 is 0. Is 0 bigger than negative 1? Sure it is. So my answer makes sense. Now I can plot this on my number line. Again, in the negatives, remember that we're always in. We got to really think and make sure that our number line is labeled correctly. It goes the opposite way that positive numbers do. So this should be negative 6, negative 7, negative 6, negative 5. If t is bigger than negative 6, we leave an open dot on negative 6 because it can't be equal to negative 6. And if t is greater than negative 6, we're going to shade towards the bigger number, towards that negative 5, or the right. Also, if our variable is on the left, the arrow points the same way that we shade, which is also to the right. So we keep going with these one-step inequalities at the top of the next page. Here I have negative 2/5 x is less than negative 8. The inverse of multiplying by negative 2/5 is dividing by negative 2/5. So you can divide both sides by negative 2/5. Or you can recognize that this is the same thing. Dividing by negative 2/5 is the same thing as multiplying by the reciprocal. I don't care which one you do, and just as long as that you show it. So x is less than, in order to divide fractions, we keep, change, flip. So this is where, again, if you multiply by the reciprocal, I'm okay with it. Multiplying by negative 5 halves, the 5's cross-reduce, the 2's cross-reduce, so I am left with 1x here, and then over here I multiplied by the reciprocal. It's the same thing as dividing by what we multiplied with. A negative times a negative is a positive, but I did multiply or divide both sides by a negative, so my sign has to flip, and I get x is greater than, the 8 and 2 cross-reduce to be 4 and 1, and 4 times 5 is 20, 1 times 1 is 1, and so 20 over 1 is the same as 20. In this situation, x is greater than 20. If we check our solution, pick a number bigger than 20. Let's pick 25. Negative 2/5 times 25 over 1. I want to know, is that less than negative 8? Well, the 5 and 25 cross-reduce to be 1 and 5. 2 times 5 is 10. A negative times positive is a negative. Is negative 10 less than negative 8? It sure is. So my answer of x is greater than 20 seems like it makes sense. On my number line, I'm going to label it this time 15, 20, 25, just to remind you that as long as you have one number bigger and one number smaller and things are equally spaced, I don't care which numbers you put on your number line, but it does need to be in the correct order, does need to be equal spacing, and your number that you're graphing needs to be in the middle with one number smaller and one number bigger. So x is greater than 20 means that it's not equal to 20, so I have an open dot on the 20. Bigger than 20 means I'm going to shade towards the bigger number. In this case, that's 25, and fill in my arrow. And then example number 4, I have negative 9r is greater than or equal to negative 6. When I do this one, I'm going to divide both sides. The inverse of multiplying is dividing. I'm going to divide both sides by negative 9. And so r is, I'm going to flip my sign because I divided both sides by a negative. Less than or equal to negative 6/9 reduces to, or negative 6 over negative 9 reduces to 2/3 because 3 goes into both of them, so we can write this as a fraction. And r is less than or equal to 2/3. So now when I plot this on my number line, I'm going to do 1/3, 2/3, 3/3, which is really just the same as 1 whole. Doesn't matter which one you put. And if r is less than or equal to 2/3, it means that it's got a closed circle on the 2/3, or it could be smaller, so we can shade to the left towards the 1/3. We can also shade the way the arrow is pointing since our variable's on the left. And if we want to check our answer to make sure things make sense, I could pick 0 because 0 is less than 2/3. So negative 9 times 0. I want to know, is that greater than or equal to negative 6? Any number times 0 is just 0. And 0 is greater than negative 6, so my check works, my graph seems reasonable, and my answer seems reasonable. So whenever we're solving inequalities and we multiply or divide both sides by a negative, we flip our sign. If you only multiply one side by a negative, like we did in example 2, remember that we do not flip our sign. It's only when we multiply or divide both sides by a negative that our symbol, our inequality symbol, needs to flip.